All right, so today we're going to work on how to find the molecular formula. We did how to find the empirical formula, and you had problems on that. So today we're going to take that one step further, and we're going to do this by doing a very simple problem, and then we're going to have like a you try, all right? Well, actually, we'll have a we try, a we do together. So in this simple problem that we're going to use as an example, we are given, so this is a given, the empirical formula is CH2O. And also given is the molar mass, which is 180 grams per mole. Now, there's been a question, somebody raised a question earlier on what's the difference between the empirical and the molecular formula. So I'm just going to quickly remind you, the molecular formula is the actual formula, and the empirical formula is the smallest whole number ratio. So for example, if my empirical formula is this, my molecular formula is this, so this would be molecular formula, then my empirical formula would be this. Okay, so my molecular formula is actual, and my empirical formula is the reduced. All right, so this is my empirical formula, but my molar mass is 180. So the first step is going to be to calculate the empirical mass. So to do this, I'm going to add up the mass of my empirical formula. So I'm going to take CH2O, that's my empirical formula, and I'm going to take 1 carbon, 2 hydrogens, and 1 oxygen. So 12.01, 2.02, and 16. And that gives me 30.03 grams per mole. So my calculated empirical mass is approximately 30. And we'll leave it at that, because we're just going to do approximates for this, all right? So that's 1. 2, I'm going to divide the molar mass, which is given, by the empirical mass, which I just calculated, and that is going to equal my multiplier. Now, you might remember that the multiplier is the number between the molecular formula and the empirical formula. So my multiplier here is 2. Okay? So my multiplier. So in this case, I'm going to take 180, I'm going to divide it by 30, and that's going to give me 6. So my 180 here is my molar mass, and my 30 is my empirical mass, and then this is going to be my multiplier. Step 3, because remember, we're trying to find the molecular formula. Multiply the empirical formula, the empirical subscripts, by the multiplier. So that would be 6 times my empirical formula, which would equal C6H12O6. And that would be my molecular formula. All right, and by the way, this one has a molar mass of 180, right? Grams per mole, and that was given. Okay, so this one has a molar mass of 30. This one has a molar mass of 180, 6 times that. This one has a molecular formula of C6H12O6. This one is a formula of CH2O, 6 times that, all right? So that multiplier is both in the formula and the mass, all right? Okay, let's do an example. Here we go. Find the molecular formula (40.68% carbon, 5.08% hydrogen, and 54.24% oxygen. Molar mass equals 118.1 grams per mole.
We have to calculate the empirical and then.
Yeah. So here we go. Okay, so first, empirical, 40.68. Okay, so we're all set up to calculate the molar ratio. So we're going to convert all these grams into moles, right? And then we're going to divide by the smallest number of moles to find that ratio. Okay, so this is where I ended up with my moles. Once I divided by my smallest number, I got 1, 1.5, and 1. So I'm going to multiply these by 2, and that's going to give me an empirical formula of C2H3O2. So far we haven't done anything that you don't already know how to do. But now I need to calculate my empirical mass, because in order to find the multiplier, I need to divide my molar mass by my empirical mass, and that wasn't given in this problem. So I'm going to need to calculate my empirical mass. So to do that, I'm going to take 2 carbons, 3 hydrogens, and 2 oxygens. So 24.02, 3.03, and then 32. So that gives me 59.05 for my empirical mass. Yes. So I multiplied them all by 2.
But like in any other situation.
I multiplied them all by 2 because it's 1.5.
But if hydrogen was 2, then you would.
Right. So if hydrogen was 2, 1, 2, and 1, I would have left them as is. But because it's 1.5, I need them all to be whole numbers. So, yeah.
So no matter what, if you get like close to 0.5, maybe 2.5, 3.5,
Multiplying by 2. Right. And so, in other words, if it was 1.25, I would multiply by 4. Because the 1.25 would go up to 2, right? So then I would have 5 times 4, and that would give me 5.
So you're always rounding to a number that can be multiplied into a whole number
Yeah, they should come out pretty into something that can be multiplied into a whole number. So for example, it could come up into 1.33, and that would be multiplied by 3, and that would give you 4, right? But it should not come up into 1.58, because what is that? That is garbage. That's nothing, because we're not in college, we're in high school, and that's not pretty. You know, or 1.88, that's terrible. No, that is something went wrong. Should be something pretty, like a third or a quarter or a half or 3/4 or, yeah. All right. Okay, so the next step is to divide our molar mass, 118.1 divided by 59.05, and that gives us 2, which is our multiplier, 2. Okay? And then we're going to take 2 times C2H3O2. So that gives us our molecular formula of C4H6O4, and that is the answer. Yes, the 118.1 was given. And this, by the way, has a molar mass of 118.1 grams per mole, which was given. That's correct. All right? Okay.